The solution to Alzheimer's is not going to be a drug that clears out protein deposits in your brain. This has been done and tried before, and it has a very bad track record. That said, there's a paper in Nature Neuroscience that gives us a glimpse into what might be the future for the treatment of Alzheimer's. Let's first talk about what accumulates in there and why clearing it is not as simple as the marketing makes it sound. At the biological level, Alzheimer's is protein garbage piling up in the brain. That's the definition from this old guy called Alzheimer's. To make it simple, we have two specific proteins that are big in the brain of the Alzheimer patient. One is beta amyloid. Two is this thing called phosphorylated tau. This is the tau protein that has been misfolded, and therefore it is a mutant protein in the brain. It's crazy, but this idea of trying to scrub out the protein deposits in the brain has been used by drug companies for around 30 years already, since 1992, and its track record has been underwhelming. Even reviewers who are sympathetic to this cause are still trying to hedge their bets. This means that they haven't really found the conviction that this drug really works and the patients really feel it makes a difference. So remember, we spoke about beta amyloid. Well, there are 3 drugs you should know that are for beta amyloid, and research on them have been ongoing since 30 years ago. The first is aducanumab. Its history you can read online. It's abysmal. It's sold as Aduhelm, and it was later withdrawn from the market because it was not a commercial success. And then came lecanemab and donanemab. This is the review of both of them. So what does incomplete mean? Basically means that it's not convincing enough that these drugs actually work. So far, we've been talking about clearing out the beta amyloid, and that has been the drift for a while. But did you know that the bigger impact actually comes from clearing out phosphorylated tau? So you can think of phosphorylated tau as the real bank robber who goes into the bank and does the bad deed. It causes neuronal death and also cognitive decline. What about this amyloid beta? Think of it like the getaway driver. It brings phosphorylated tau so that the bank robber can go in and do the bad deed. Beta amyloid just hangs out in the car, waits there while all the bad things happen. So drug companies know that phosphorylated tau is the real culprit, and they've done everything they could to go after it. But that whole drug pipeline targeting phosphorylated tau has been an absolute graveyard. Names you probably have not heard of because none of them actually made it. So then you can understand, if this clearing of the tau doesn't work, maybe let's just clear the amyloid, right? Because Alzheimer's is defined by amyloid beta anyway, so let's try to clear it and maybe tau will clear. But the science is becoming very clear now. It doesn't work. So what are the side effects of these drugs that are supposed to help you brain better, to help increase your cognitive function when your cognitive function is already dropping? What are the side effects? You can call these side effects ARIA, A-R-I-A, and it's a euphemism for, number 1, brain swelling, which is called ARIA-E, or brain hemorrhage, which is called ARIA-H. And this is the track record of side effects. ARIA-E, brain swelling, 24%. ARIA-H, 31% for the drug donanemab. And for those who are at the highest risk, they are called APOE4 carriers. And if they are APOE4/4, which is homozygosity, their chances of brain swelling are even higher, which is close to 42%. Imagine being APOE4/4 and using this drug because you feel your cognitive function is dropping and having almost 50% chance of your brain swelling. No good. And somehow the drugs are still pushed forward, and they have measures, of course. So the measures are measuring your propensity to ARIA-E or ARIA-H. And of course, if your propensity is high, you are not such a suitable candidate. Doesn't it sound like these drug companies are hitting themselves against this brick wall? This method doesn't seem to work. So we know across the board for these anti-amyloid drugs that about 20 to 40% of these people undergoing active treatment have brain swelling and or brain hemorrhage, some of them fatal. So back to the analogy, these drugs, lecanemab and donanemab, they target the driver, the getaway driver. They don't target the bad guy in the bank robbing people with a gun in hand. And before we move to the point made by this paper in Nature Neuroscience, let's go a little in the anatomy. Amyloid beta is the gunk that forms between cells in the brain, which are called neurons. So you have neuron, and between them, you have amyloid beta, right? So these drugs are trying to clear them out. But the problem is phosphorylated tau, right? Phosphorylated tau is in the cell, in the neuron itself, and it mutates within the cell. And we know that these drug companies have tried to clear out the mutation within the cell already, and it's been a failure. Now, this paper is saying that in the cell itself, there are processes that help with the cleanup so that the tau does not get mutated at all. Neurons have this garbage cleanup system right at their membrane, and it points to this thing called the neuroproteasome. And when it's working properly, it stops tau from mutating. So now, hopefully in the future, we're not just banging our head against the wall, trying to clear out protein deposits that have already been formed. And science will be asking this question instead. How do we help these neurons, which already have a garbage disposal system, to continually clean up itself? And hopefully, we find some answers here instead. Right now, it's still early days. Research on neurons and maybe mice, and hopefully in the future, we will have human studies. I talk about dementia prevention and the brain in Midlife Brain Project. That's all I want to share today. Hope this is useful information. Thank you for listening. Bye.